If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate measurement series. So today we will be solving 5 questions starting from question number 66, 67, 68, 69 and then 7. Okay, then let's try to solve these questions. So in 66, the voltage phasor of the current is 110 angle 15 degree. The current phasor is 2 angle minus 45. The active load and the reactive powers in the circuits B. So this in phasor notation, this is a standard notation that as complex power we always assume it Vi star, which is we treat it is at P plus JQ. You can take it, consider it P minus JQ. In that case it will be V star I. So whatever way you feel comfortable. So generally this way we go. So it is V is 10 angle 15 multiplied by 2 angle minus 45, then it's star. So it is P plus JQ. So you will find active and reactive power both here. Multiplied by 2 angle 45. So angle will be added, magnitude will be multiplied. So 20 at an angle of 60. So 20 cos 60 plus J 20 sin 60. What is 20 cos 60? That is 10. What is J sin 60? That is multiplied by 20. Then it will be 17.32. 0.866, that multiplied by 20. So your P is equal to 10 and your Q is equal to 17.32. This much kilowatt, kilo, not watt, kilo, it is simple watt, and that is this much var. Because everything is in volt in current, so it will be in watt and kilo var. You know why this star is given? This star is given to capture the angle between V and I. Because you need V, you need I. What is your formula? Vi cos phi is the and Vi sin phi. So this angle should be the angle between these two. So here V is you at 15 degree. V is here. V angle 15 and I angle 245. So what should be the angle difference between two? 15. This is minus 45. So 15 minus 45. The angle is 60. So that's why the angle is captured. If you don't take that star, that will be minus 45. So it will be 15 minus 45 minus 35. This is not the true angle between these two. So to know the angle between these two, you have to subtract. Because if you suppose this is theta 1, theta 2, you want to know the angle between. Suppose this is V and I. You want to know the angle between them. So this minus this, or this minus this, you have to take it. So that's why this star came into the picture, to capture the angle between V and I. That is to capture Vi cos phi or Vi sin phi. You can say it is Vi, V into I, 10 into 2, and it is the angle between them. That's it. Now if you come to 67, the moving coil dynamometer wattmeter is normally connected. The moving coil dynamometer wattmeter, you know the dynamometer connections. So there is a moving coil, there is a fixed coil, and then this is the load. This is your supply side. This is moving coil, this is fixed coil, and this moving coil is nothing but a pressure coil. And this is current coil, CC. So fixed coil is nothing but your CC also. Moving coil is nothing but your PC also, pressure coil. So it is the moving coil that is connected across the supply. This is your supply side. So it is connected across this supply. The dynamometer is normally connected across the supply. That is your option B. To come to 68, the water boiler at home is switched on to AC, means supplying power at this much. The frequency of the instantaneous power consumed. Now what is instantaneous power? If B is equal to your Vm sin omega t and I is equal to your Im sin omega t, then power is equal to Vi. Instantaneous power is instantaneous voltage into instantaneous current. So if you take product of this, and this is nothing but your, because it is a boiler, a water boiler, so you assume it to be a purely reactive heater. So we are assuming, purely resistive. So we are considering it is R, then sin omega t. So no angle change. There is no phase change between them because it is purely resistive. So if you take product of these two, that is Vm square by R, then sin square omega t. So sin square omega t, you can write it 1 minus cos 2 omega t by 2. So it will have two portions. One is your DC portion, that is Vm square by 2, and one is Vm square by 2 cos 2 omega t. Now you can see the signal, how its frequency is changing. So this is the way the frequency is changing. What is its frequency? It is double the original supply frequency. Original supply frequency was omega, but the instantaneous power frequency, because it is changed, this is fixed, this is not changing. So if you add these two, ultimately it will change because of this. So the frequency of this one is nothing but 2 omega, so it is twice. So that is if your original frequency is 50, it will be 100. So instantaneous power frequency will be 2 times of 50. You can see it is 2 omega. The dynamometer type wattmeters respond to average value of the active power, average value of reactive power, peak value of active power, peak value. So whatever we calculate, Vi cos phi, that is nothing but average value of the active power over a cycle. So it is the average value. So because your deflection torque in electrodynamometer type wattmeter is directly proportional to your Vi cos phi. So if there is no error, everything is well and fine, then we can say it is directly proportional to this. Generally there is a problem in this phi. We will see in coming questions there is a question. Okay, so it is directly proportional to and this is nothing but your average active power. So that it is always active power, average active power. So that is your option A. It is directly proportional to average active power. If you come to 70, the electrodynamometer type wattmeter have a large error while measuring the power in AC circuit at low power factor conditions, since the voltage across and the current through the you will see this one, this pressure coil is not in same phase. Why this is so? That's what I was telling. There is an error in this one. So whatever you give supply in because the connection you have seen, this is your pressure coil, this is your current coil, pressure coil and current coil. So we assume whatever we give supply, this, suppose this is your V that you are giving supply and this is your measuring your I. So due to this V, there will be a current flowing in the pressure coil, and that current we assume it that is in the phase with this one. If it is in the phase, and suppose this is your IC current, that whatever load, suppose it is a lagging load, so this is your phi, so this is your V. So torque produces due to the interaction between the fluxes, that is between the current. So this your torque that is produced, that is this one, this phi. So this is your torque is directly proportional to, you can say, Vi. This V is coming, this V is directly coming, not coming, it is coming via through this I that produced. So between these two I only. So you can assume it this is of this fashion. But what happens, due to its inductance present in the pressure coil, some inductance will be always present, this current is not in phase. So because this is not in phase, what it will look like, so this is your pressure coil voltage, so this is your pressure coil current, and this becomes your original current IC. So now you see this is your original power factor angle phi, but there is angle theta between these two. That's why it will not directly proportional to now Vi cos phi, it will directly proportional to Vi cos phi minus theta. So that's why a correction factor is generally required in case of wattmeter. And what will be the correction factors for lagging load? Let us write the correction factor. Lagging load correction factors CF is equal to, you need Vi cos phi, but you are getting this one, so you need to divide it by this material. What is the material? Cos phi minus theta. You have to divide it this one, and then it multiply by cos phi. So this deflection is, because you are writing in terms of V and I, that is cos theta plus phi. This is the angle between this and this, and this IP that comes into picture, directly Vp is not coming. So how much of Vp is coming? Vp cos theta is coming. So it is actually also cos theta is also there. So that is also coming there. So that's why you need to divide with cos theta, because here the total effect of V is I, that is coming here. Divide by R, that you forget about, because we are interesting, because it is directly proportional. So accordingly we will change our K constant. So that will not change the angle. We are interested about angle. But here you can see this is Vp. The entire Vp is not coming. So some portion of Vp is coming. This portion is nothing but Vp cos, that is vector. If you dissolve Vp into two parts, this is Vp cos theta, Vp sin theta. So Vp cos theta portion is coming. So that is Vp cos theta in this current. So it is Vp cos theta into this current into current and angle between these two. Here you can say okay, Vp by I. Here also Vp by I. You give it, then it will be okay. R we are neglecting because it is proportionality constant. So it will be R is constant here. You multiply this one by the reading, then that will give you the exact answer. For leading also now you can easily derive. For leading it will be theta plus phi. That's it. Nothing is different. Now what happens in case of low power factor? Now if you see, suppose it is of high power factor case, then we will come to low power factor case, high power factor case. So this is my original supply voltage, and suppose high power factor is 1, suppose that is the angle is 0. So this is your supply voltage, this is your voltage also, this is your supply voltage, this is supply current Vi, and suppose your pressure coil voltage, there is a angle that is theta. Here phi is 0 and some theta is there. Okay, so due to this, what will happen, it will measure some angle of this one. It will not come exactly. So some angle comes, mean cos something, cos 1 degree, 2 degree, 3 degree, something will come here, because it will be, you can see it will be cos 0 minus theta into cos theta. So it will be cos square theta. So whatever cos theta comes, then it will be square of that one. Okay. So normally it should have been Vi cos phi. Cos phi is here 1, so it should be Vi. Suppose my V is 5, I is 2, so it should have been 10. Now suppose your cos phi, this cos theta, this theta component, due to this there is a change, and that change is, how much change it will be? A angle, a small angle, suppose 1 degree, 2 degree, 5 degree. So it will be cos of that one will be 0.9, suppose. So it is not 1 now, so it is V into I, 5 into, this is the actual, this is 5 into 2 into, instead of multiplying 1, now you are multiplying by 0.9, so it is 9 watt. So there is an error, you can say. Okay. Now in case of low power factor, the same question, if it is a low power factor, same 10 volt, 5 volt and then 2 ampere. But the angle is very high now. Okay. Suppose the angle is so high that your actual power should be Vi cos phi. So it is 5 into 2. Suppose your power factor is very low, 0.1. This angle is very high. So it would have been a suppose, or 0.2. So it is 2 watt. Now because of error, so what will happen because of error? This angle will get little bit reduced. You can see this angle will get little bit reduced. This is nearly 1 because this is very small. So main problem is here. So this angle is, so your reading will be Vi, that is 5 into 2, and this 0.2 will get little reduced, 0.1. You can see it will be 0.1 because here also it is reduced, so here also it is reduced. So it will be 1 watt. Now you see the error percentage. Here it is error of 1 watt out of 10 watt. So what is error percentage here? 10%. What is your error percentage here? You are measuring 2 watt out, actually is 2 watt, but your getting is 1 watt. So error is 1 out of 2. That is 50% error. So it is not feasible. 50% error means how you can take this. So it is a huge error. Error percentage goes very high because your measurement is so low. Even in that one, that type of error will give you lots of percentage because you are measuring a low. Now why all these things are coming? Because there is angle with this. If had it not been angle, it would have been give me a perfect result. So that's why there is this is the idea. The pressure coil and the current, the voltage and the current through the pressure coil are not same. This V and I, it should have been same, but it is not same. If you like the video, then press the like button and please give your valuable comments in the comment section.